Hi, just real quick before we start, I just want to let everyone know that I have signed up for an account at GitHub. So the code that I'll be making from here on out will be updated and pushed into this code repository. I'll put a link down below, but I think the URL will be, github.com/zionviller/nature of hex. And I'll put that link down below. And then when you click the link, you can just download the zip right here. Or if you have, GitHub, this Windows interface or whatever it's called, installed, I think you can clone in desktop and it'll clone it to your computer. In the future, if you need the code that I'm making, it'll be here. But keep in mind, if you're watching this in the future, the code might have changed from what I'm making in this episode. But I'll try to be sure to leave notes and comments of of how things change and how to use the code. So if you come back to it at any point in the future, you'll know what is going on. So let's get started. Hello, and welcome to the next episode of the Nature of Hex vlog. Today, or last week, we were working with uniform distributions like this. This is what we should have from last time. And it's fairly regular. I mean, although it looks a bit jagged, essentially, in the end, it'll average out to about the same, regularity. But today we're going to work with some non-uniform distributions. So I think, as I mentioned before, in nature things often arise in bell curves. So for example, if this were a sample of people who are really short and really tall, the actual distribution of short people and tall people isn't even like this. There's a higher number of average height people and a small amount of very short people and a small amount of very tall people. So, how do we make those numbers appear in our code? If you have been reading ahead, we will be going in and affecting how certain values will come up. For example, the bell curve. But before we do that, let's just work with, sort of tilting the odds in certain directions. Read this, you'll learn about probability, and so let's just get right into the code. So before, when we were randomly picking a number like 1 through 5, we would, get, 1 1/5 of the time, 4 1/5 of the time, and so on. But now, let's make our numbers prefer other things. So if we look at this example here, they're making an array of 5 items, and inside the first and second indices, I believe, have a 1 stored in them. The third one has a 2, and the fourth and fifth have a 3. So we have 2 out of 5 chance to get a 1, a 2 out of 5 chance to get a 3, and only a 1 out of 5 chance to get a 2. So how would we do this kind of thing in hex? So let's give that a try. Okay, so I just went through and commented out the stuff that we don't need. I think I'm going to go through and clean this up and make its own object in the future, and it'll be in the GitHub repository, so check that. I'll comment it and make sure that we know how to use it in the future. But yeah, let's just get to making weighted probability. So in our new function, let's do this. So in their code, I believe they make a, let's say there's a, I think we'll just work inside the new constructor here. So there's going to be a new, we'll just call this set of nums, oh sorry, a new variable, and that's going to be our, we don't need new, sorry, I'm forgetting how to code. So we just put variable, set of nums, and that's going to be an array of integers, whoops, square brackets, and let's just put a literal in there. So let's do what they did. They had 1, 1, 2, 3, 3. And then let's just do a for I in 0 to set, oops, set of nums dot length. So actually no, let's not do that. Let's do that 10 times. What we're going to do is we're just going to randomly pick one of these numbers 10 times. So if we put, we'll have a variable which will be our random number, which will equal math random times set of nums length. And then remember again, we need to make this an integer, so we'll floor it. So we're going to get a number between, essentially between 0 and 4, which will point to one of these numbers. And then let's just trace set of nums, and it'll be our random number that we picked. So hopefully we should get 10 numbers, and we should get more 1s and 3s than we do 2s. Oh, what did I do wrong? First, I'm missing a semicolon. What did I do? Oh, that's right, not square. We need angle brackets. Okay, there we go. So yeah, look at that. We have lots of 1s, a couple of 2s, and a couple of 3s. And keep in mind, this is pseudo-random. So sometimes you might get, you know, an equal number of 3s and 2s. So let's run it again and see what happens. This time we got a lot of 1s and a few 3s, but no 2s. And one more time, just for good measure. Looks almost even this time. We got quite a few 3s, a few 1s, a few 2s. What happens if we take out a couple 3s, add more 1s? Now 2s and 3s are quite rare. Let's see if we run it 20 times. Bam. And that time we got all 1s. But yeah, that's just the way the numbers rolled out. So essentially, using that kind of probability, before, remember when we had the random walker, like, you know, 1 was up, 2 was down, or whatever, you could have it be biased to a certain direction. But that's a little bit cumbersome, but maybe that's a good way to give it some bias. But another thing we can do is work with percentages. So just right quick here, I'll just explain it and then we'll play with it. So right here they're making a new variable with 0.1 as the value. So that's a probability of 10%. And then we get a random number between 0 and 1 here. So if this random number is less than 10%, it will go again, you know? So using that kind of logic, what happens if we chain some ifs? So we have an if less than 6%, else if less than 7%, else it'll continue on. And keep in mind, this is going from a lower probability to a higher probability, because if it gets caught by the lower one, it'll just exit out earlier than it should. So in this case, and look right there, we have the walker kind of, you know, trending that direction. So let's bring back our walker class that we have here. So let's see, we can bring back our walker, and we can bring back our walker here, and inside of the loop, let's see, we're going to update, and we're going to update our walker. Okay. Good. And just to give a quick test to see if our walker still works. No, it doesn't look like it. Because we're not drawing our walker. So inside of draw, let's do this. So this graphics draw circle, and it'll be our walker X, our walker Y, and our radius, we'll just do 16, like that. And we don't have a start fill, do we? Let's put that in real quick. This graphics start fill, what was it called? Begin fill. And the color will be, let's see, insert color. Let's make it that color. Maybe mute it a little bit. And I forget, did we need, yeah, I think we can just use that number as is. And alpha will be 1. Good. Now we should have that little purple circle moving around. Okay, good. And let's get rid of the trace here. Actually, let's just get rid of that altogether. Okay, so we just have our circle jumping around like that. Okay. And so let's go into our walker class. And before we had step, which just does this normal step, let's make a new function, public function. We'll call it a biased step. And it'll take an elapsed, which is a float. And it doesn't return anything. So this time, let's see. Let's see what they do. So they just use the 4 directions like that. So yeah, let's just use that same thing. So 20% chance of moving up, 20 down, 20 left, 20 right, like that. So I think that'll be less than 20, less than 40, less than 60, and else, like that. So let's make it. So it'll just be a train of if-elses. So we'll do var be our random equals math random, and this time we'll just take the math random number raw because it already sends back a number between 0 and 1, but not including 1. So if, I'll just start the chain here, else if, and then I think I can copy these, oops, paste. What did I do? Alright, copy this, copy, paste, and then we'll just do an else at the end. Oh, we don't need the brackets there. Good. So if rand is less than 20%, we'll do this. If it's rand is less than 40%, it'll do that. If random is less than 60%, it'll do this, and greater than 60%, the remaining 40%, we will do this last part. So what we're going to do is, if we want it to be biased to moving to the right, let's just put that in first. So x plus equals, let's see, speed times elapsed. Yeah, that should be good, right? So it's going to want to go right more than these other ones. So let's just do x minus equals speed times elapsed. And we'll just copy this and put y here, paste it again, we'll change this to a plus and change this to a y. Okay, so when we come back here, instead of running just our walker step, we're going to run, what was it, biased step. So when we play this, see, ever so slightly, it should try to make its way over to the right. Actually, so we can see it, let's get rid of the clear and let's make the color like 0.5 opacity, just so we can kind of see the trail that it leaves. So hopefully as things go on, we'll see it, yeah, see, this time it's really heading over that way. But yeah, it's biased 40% of the time to go to the right. So that's one way we can sort of make certain amounts more likely than others. With that first method though, it could be good because maybe you want it to procedurally make these percentages. Maybe just dropping the number into an array or the result into an array that you want might be good. But I don't know, I've never really used it, so alright, so moving on. So actually that's it for this episode. Yeah, so that's one way we can work with non-uniform distributions in our randomness. I keep talking about the bell curves, but that's not until the next episode. So yeah, next up, and it's gonna be a little bit of math heavy episode because processing has a built-in class called next Gaussian, and we're gonna have to make that. So I hope you're ready for some math. Anyways, don't mind me. Alright, so yeah, that'll be it for this episode. I'll catch you next time when we talk about Gaussian distributions. For real this time, though. For real, for real.